Welcome back to our extremely ambitious hydraulics build. In our last video, we successfully fabricated 4 huge telescoping legs designed to raise our truck and get him level and solid wherever we park him. In this episode, we'll finally find out if our weeks of hard work were worth it. Can we lift moose? How much does this whole system weigh? And how much money did we actually save? Let's find out.
So if you watched to the end of the last episode, you would have seen me with this thing and all the wires and stuff. And this is the wireless receiver that controls this thing. Didn't really show you much of this. This is our valve block. So you'll see it has 8 ports, 2 ports per leg essentially. And these black bits on the top and the bottom, if I take that off, you'll see they have electrical connectors. These are solenoids. And basically what happens is when you power, say this one, the little valve inside moves up and it lets fluid come out of this port, which would, for example, lower the cylinder. And when you power this solenoid, it would do this one, which would raise the cylinder. When I push a button on here, it will send electricity down one of these cables, which will be connected to the solenoid, which will pull the valve. So we just have to basically figure out which wire relates to which button and then wire that wire to the right solenoid, and then that's it. Easy.
Do you need to power the pump?
Yes. Also, every time you trigger a solenoid, you also need to turn the pump on. You can just have the pump running, but it's not very good practice. Really, you only want the pump to come on when the valve is open. That sounds a bit more complicated, but again, it's not. It's just another 8 wires. I think now that's it.
So you've got 8 buttons, 8 valves.
4 legs, 2 directions each.
Yes.
Yeah. Just fitting our new battery terminals so we can power everything. We've got a couple of bits to do. Got to crimp up some cables as well, which will be fun. I've not done that before. I had to buy another tool.
What a shame.
It's really annoying. So this is for crimping like battery terminals and stuff onto big chunky bits of wire. Okay, so now got a little box of terminals.
That's cute.
I know, and then that will go on the battery just as a real secure fitting. It goes in. He goes in there.
Wait.
Squeeze. I think that's crushed. There you go. One crimped on battery terminal.
Oh, very neat.
So, I didn't bring a light or anything. Have we got one? I think it's heat shrinkable.
I think we have a blowtorch.
Ah, that'll do. Oh, this isn't heat shrink. This is just plastic that's now on fire. But it's okay. I've got some really good marine grade heat shrink that's got glue inside, so when it melts it makes like a waterproof seal. Okay. That's a good watertight connection. So we got our positive and negative wires coming over, and now got these 2 positive wires and a mega fuse. It's actually called a mega fuse. I don't know why. I don't know what it stands for. Thought it'd be best to put one in. Even though this isn't the final thing, I still just want to put a fuse in just in case. Put his little cap on.
Mega fuse.
Mega fuse. If we just connect the batteries up fully now, we could just test the motor to see if it works. Okay. Come in close. This bit here, where the positive comes in, this is a relay, and this little pin here, you put electricity to that and it flicks a big switch in here, and that's what powers the motor up. It's like a relay in here essentially.
What are you gonna do? Just touch it?
I'm gonna close those two. Yeah. Ready?
Mm. Oh!
Okay, maybe we should strap this down. But there you go. That's how it works. If you hold, hang on.
No, I'm not going anywhere near it.
It's safe. It's fine. It just is bouncing around a little bit. Yeah, I can't hold it down, but yeah, it works. Okay, that's a very good sign. Now we can wire all the solenoids up to the controller. Okay, we're making good progress. We couldn't figure out why it wasn't working yesterday. We thought we wired it all up properly, but we could hear the relays clicking inside the receiver when you push the buttons, but our solenoids weren't doing anything. Couldn't figure it out. Did a bit of research and it turns out to be translation error. So in the manual, and written on there, you have these cables that say COM1, COM2, COM3, which usually in DC is like a common ground, but no, it means control unit main power, that was it, which basically needed to be a positive, not a negative. So we weren't breaking anything, we weren't shorting anything, but we weren't sending any power anywhere. So we've wired it all up properly now, bit of a mess, but now if I arm the remote, press start, this is our up solenoid, this is our down one. It's working. Hang on, let me put the mic nearby. Pretty cool. So we're just going to finish wiring them all up, just kind of temporary, just so when our hoses come in a couple of days, we can test it all out and actually get things going. Off. Okay.
I'm gonna listen for the clicks.
Okay. Yeah,
I think so.
They all work.
Okay, you got it. I'm glad. I was worried this was the wrong thing.
Yeah, me too. I thought I might have messed something up.
Can't wait to make new buttons.
So now we need to get the pump running. So what we could do, because there is a start button on this, we could make it so that as soon as it's turned on, the pump runs, but you don't really want to do that because unless the valve's open, the fluid's got nowhere to go, so it'll just build up pressure, and you can also burn out the motor as well. So what we need to happen is when I push a button, it opens a valve, but at the same time it turns the pump on. It's quite simple. All these white wires are the positives that go to the solenoids. So basically in every solenoid we take another positive wire off and go to the relay that turns on the pump. But what that would mean is that all the solenoid positives would actually be connected together to the relay. Whenever you trigger one, it would actually trigger all of the solenoids, so all the hydraulics would move, which wouldn't be good. So we need to basically restrict the flow of electricity in the simplest way of putting things. And you do that by using these things. These are diodes, and they are essentially like a one-way valve for electricity. So that means that when we send a signal from the solenoid to also turn on the pump, the electricity can't also go into all the other solenoids and trigger those at the same time. Does that make sense?
Yeah.
Good.
So now we need to make 8 positive wires with a diode in line.
Yeah. Yeah, so there you go. This end will be on the solenoid. This end will go to the starter. Electricity can go this way to the starter to tell the motor to turn on. So put a bit of heat shrink on that and hide it, and it'll look real good.
I prefer this to the blowtorch.
It's a little safer, isn't it? Okay, so we've got our first solenoid with the diode connected to the motor. So now, if I push the up button, it should trigger this solenoid and turn the motor on. Okay, it's armed. Oh yeah. Yeah. Okay, it works. It works.
That's good.
Nice job. Should we do one last test?
Okay.
On. Yep. 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 It's hard because the sound of the motor overpowers the sound of the solenoid, so we won't really know if we've done it right until we have all the cylinders plumbed in. But I think it's pretty good. Oh.
We're still waiting for the hoses to come. They're being made. Hopefully we'll get them very soon. So in the meantime, we're going to sort out the aesthetics. We're going to use a few different products. We're going to use our really thick epoxy paint on the exterior and on the cross members and on the outside of these legs. For the inner legs, we don't want to go too thick because we don't want to risk them not being able to slide anymore. So we've just got some primer and some spray paint for that and give it a thin coat. And then on the insides where we really can't reach, we're going to use a wax oil. And this is Nutri-Rust wax. It's the same company that made our rust converter. So we'll give this a try. The rust converter is really good. And then we'll also stick it over the top of everything once the paint's dry as well, I think, just to give it some extra protection. But for now, we need to take the inner legs back out and I'll get those painted up while Pete welds on the little tabs. If you missed the episode where we built all of the legs for the hydraulic system, you definitely need to go back and check that first before you watch the rest of this. Otherwise, it's not going to make any sense.
Plus, it was just really cool to see. So this is how we're going to keep the leg in an upright position when we stow it away. Basically, we're going to have one like this, and another one like this, and another one like this.
How about when you want to like reach it from the outside when there's a box on there and stuff? It's not that far under, is it?
No. A few people were wondering like how difficult it's going to be to get the leg up when the habitat's on and stuff. But yeah, we'll just have to make sure we leave a decent amount of space on either side. Okay, we're going to use our nice fancy new hitbox welder. A few of you were asking where to get one of those welders from after seeing it last episode. Amazon is the best place because they've got 20% off at the moment, and if you use the link in our description it also helps us out. So I'm going to tack them in place first. Yeah, I've just tacked them in for now, but if I take this strap off, pretty cool. So that'll just go up like that.
Yeah, they look good.
Yeah, looks very professional looking, doesn't it?
Yep.
Shame you're not going to really be able to see them. So we do need to figure out a way of putting the legs away and stuff without having to like crawl under the truck. And we've got a few ideas, and you guys submitted quite a few ideas actually. A few of you had quite a cool idea to use like a stick that you can like attach to this and then like use it to push it up. And then it'll just be a matter of kind of reaching in here and putting it in. And what we're going to do, these aren't going to stay just normal bolts. We're going to weld like a handle onto it and drill some holes for the R-clips to go in so that it'll kind of stay in place without having to get out spanners and stuff. So yeah, that looks great. It's looking good.
First coat.
But you've painted my desk.
I'm sorry.
How was this thing?
It's good, because normally when I use them...
You get finger cramp.
Yeah, and also I end up painting my finger a lot.
Yeah. It looks so cool. Should we solve the mystery of how wide Moose is going to be?
Yeah, surprising amount of people are concerned about the width of Moose. He's only 2.45 metres.
Yeah, I think the camera added...
Camera adds £10.
I think because it's such a wide lens, and with the legs folded out,
Yeah.
it looks much wider. It's like over 200mm wider. But yeah, the width of the cross members is the width of the finished truck, and it's 2.45 meters. Legal limit is 2.55.
We've left about 5 centimetres either side for lights or door trim or whatever might stick out a bit further.
Yeah.
So don't worry.
We had a lot of comments about that. Lots of worried people. We're putting everything back together, putting all the inner legs back together so we can put them in.
It means we have the fun nylon again.
Yeah.
We're just adding a little bit of thread lock because we don't want these coming out ever. The hoses are here. Last bit, and then we can see if it actually works. I'm just going to pick up the truck, or if it's going to snap or not work at all. Everything is attached, bolted down, greased. There's not really much more to do before we can just test them. So, we need to get the cylinders in and then prime the hydraulic system.
Simple. There's a lot of parts required and a lot of planning and thought into how these hoses go, because they're not really very flexible. They can't really twist. They can bend, but they can't twist. So you'll see this one has one fitting pointing up and then the other fitting at 90 degrees this way. So you have to figure out what angles are required before you can order the hoses. And it hurt my brain. It was not fun, but I think we figured it out. Also, the ends are different depending on what they're going into. So you need adapters for everything. And each one of those needs its own seal that's the right size. They're called Doughty seals. And basically they go on any fitting that hasn't got a cone-shaped receiver. So if you have a cone on one end, but it's going into something flat, you need a Doughty seal. First thing, shall we attach the pump to the valve block?
Yeah, let's do the shortest ones first.
Okay.
So some of these hoses are like 4 meters long.
Yeah.
kind of worked.
Yeah, they did, yeah. Yeah, this isn't permanent. We're going to be routing it through holes in the chassis and clipping it to the chassis. Like, none of the hoses will be this loose. But yeah, we just need to figure out how these hoses are all going to move when the leg folds and stuff. But it looks cool, doesn't it?
We're going to build some aluminium chassis boxes along the side of the chassis on each side, and the hydraulic system is going to be stored in one of those. We will probably have one of the engineers from Interpump, which is where we got our hoses made, come and maybe reroute things for us, check that the ends are the most efficient they can be, shorten any hoses that are just too long, and maybe just kind of hand over to them and make it nice because they know what they're doing. But yeah, I think we're ready to get fluid in and start bleeding the air out of the system and maybe make the cylinders go.
I am very excited. Feeling strong?
This is too much oil. What we need, but it's the smallest they did.
So, the way you bleed these systems is we're going to start one cylinder at a time, extend it a third, the level in the tank will drop a bit. You've got to keep an eye on that, make sure it's topped up. But bubbles will come into the tank, you have to wait for the bubbles to stop, fill it up if you need to, retract it, extend it out 2/3, wait for the bubbles, fill up if you need, retract it, extend it out fully, and you kind of repeat that until there's no more air bubbles and the tank is staying at a good level.
Then we'll move on to the next.
And then we do that 3 more times. So, if I push this button, that should...
Just give it a tap first. Which way is it supposed to go?
I don't know.
Oh!
It just shot out.
Oh my god, that was a lot.
I guess because there's not very much control, it just built up air pressure and then it just shot out.
Yeah. Did you want to try and retract it now? Oh, that's the other way.
That's the wrong way, okay. Oh,
okay, we have movement.
Okay.
Oh, now I hear bubbles.
I hear bubbles.
I see them.
Okay, the bubbles have chilled.
It doesn't seem to have like a slow.
Well, I think it just shot out because there was air, so I'm just going to keep going for a bit and see what happens.
Just
see it coming down.
Be gentle.
Yeah.
Oh, that's better. And then go up.
Do we just keep doing this?
I think so.
Okay.
Maybe we should tuck that leg in though, because how long is it going to want to extend?
I don't know, I haven't extended it out all the way.
Now we'll go in, I think.
Or, yeah, I just heard more bubbles come into the tank. So, it seems like when you get past a stage where the cylinder hasn't been before, that air then gets sucked in.
Yeah, and then it's like...
It's cool! It comes out a lot. Like
yeah, it does.
The truck's going to lift up a fair bit.
Mm.
That's so cool.
And no leaks.
No leaks.
We haven't
Let's not even say
checked.
the word.
It's quick.
Yeah. Oh, what was that noise?
Ooh, I think I hit the top.
Is it in now?
Yeah.
Okay, so what button are you pressing to make the cylinder go in?
Down.
Which would make the truck go down. Okay, good. Yeah, I wired it the right way. Good.
Okay.
Cool. It's really fast.
Yeah.
It will be slower when it's under load. Is it fun with the buttons? I think that one's done.
How can you tell?
Because it's not gurgling anymore. There's no bubbles coming into the tank.
That seems too easy.
Yeah, we need to top it up a bit now. I'm just trying to figure out which button it would be. Front passenger, front driver?
Yes.
Rear passenger, rear driver?
Yes.
Okay, chuck.
Just a little bit.
There's a lot longer hose, so this might take a bit longer.
Yeah.
Oh, I heard something.
Oh!
Oh yeah, lots of air back in the tank. Now we just wait for the bubbles to go down. I don't know, I'm pointing at it. Up. That's quite a lot. And like when there's weight on this, when the habitat's on, the suspension's going to be way more compressed, and this will probably be like here, you know? Done. Okay, next one. Oh! Okay, that one's good now. How come it goes in so much faster than it goes out? Oh. Oh, there it goes. Oh yeah, lots of bubbles. Yeah, done. They're all bled. Now let's quickly put the inner legs in and raise the moose up. Were you making one go in and one go out? I thought something was broken then. Were you doing that on purpose?
Yeah.
Okay, good. I was like, oh no. Okay, we finally put the nuts on these bolts for the feet. Real quick, we had quite a few comments about how much movement these feet have, but also about the M12 bolts and if they're strong enough. I think this is enough like mobility for the foot. Like if we're resting on ground that's like that steep, we're probably not gonna want to stay there. But we can always make a bit of adjustments if we need to, but for now I think that's good. So for this whole project, we actually ran all the designs past like a proper qualified engineer. He did all of the calculations that I don't understand to work out what size box section we need for the cross members and all the bolts and that kind of stuff to make sure it was all strong enough with a decent safety margin. So these M12 bolts, they are grade 10.9 high tensile bolts. And I think what people were worried about is that they would bend, but they're not actually in a bending moment. They're actually in a shear, which is where the bolt is going through two pieces that want to pass through the bolt, like shearing like scissors. And it's that in two places, so it's kind of like a double shear. And an M12 grade 10.9 in double shear can stand about 7 tons. And obviously that's way more than we actually need. So believe it or not, they are actually strong enough. Okay, guess what?
What?
It's finished!
Ow.
It's really good. You should take a moment, just appreciate it. Okay.
That was a short moment.
So right now, we have no idea if this is all actually going to work. We've put the 2 pairs of wheels on the back, so hopefully now it gives you a better perspective of size, because the chassis does look really skinny. So yeah, they're on.
It looks very different with the second set on.
So there's a few things that we want to test. We obviously want to see if the whole system is strong enough to actually do what we want it to do, and is it going to actually make it stable and sturdy. And once we've done all that, we're going to tell you how much it weighs
and how much it's cost.
Concerns? The front is very heavy.
Yeah, my concern is that we lift up the front and then the cab is somehow too heavy, and I don't know if it would like tip and fall on its face. I think it might have a bit of a wobble.
Okay, I think first thing to do is...
You'll give it a shake?
Yeah, let's get a reference of how wobbly it actually is without its legs down. It's wobbly, like even I can...
Oh, yeah, you could do a better job on your own.
Like, okay, it wobbles a lot, so that's our reference. So we know the cylinders all go up and down, but...
We're not expecting a different result.
No, but we've never seen the legs slide up and down like by themselves, so let's see. It's so fast.
That is fast.
Okay, I'm not going to put any weight on it yet.
Oh, I can see the front one from here. Do that one.
So so cool. Okay, you gotta do the other two. What do you think of that?
I'm scared. So just go real gentle.
Yeah. The goal isn't to lift the whole truck up. Yeah, I just want to like...
To see what happens.
I'll put the
when
feet
you put,
down and see.
Yeah. Oh.
Foot has touched down. That foot is also touched down.
Oh.
Okay.
Oh.
I'm going higher.
Okay.
It's struggling a bit.
The front wheels are still down.
Yeah.
Oh. Oh.
Comes down with a wobble.
Yeah,
It's hard.
It's hard very quick.
Yeah. I wonder if there's a way of slowing it down. Okay, that leg's down. Okay.
Oh.
Okay, you ready?
Yes. It's off the ground. The wheels are off the ground. Is that as high as it goes?
No, it goes higher. Should I go for it?
Okay. That goes up so high. Oh, that's it.
That's it. Okay, I'm going to drop them back down just a little bit. But these wheels are off the ground now.
That's much higher than we need it to go.
Yes. Should we do a stability test?
Yeah.
I can't.
You were like this before. Oh, good. Well, that works.
Should we try and lift up the front now and see what happens?
No.
Why? Here we go.
Oh, crumbs.
I mean, all the bolts are holding. Everything's doing great. I like how it comes down. It's all like, woo. Shall I see if we can do all four at once?
Moose got legs. Moose got legs. Moose got legs. Moose got legs. Touch his legs. No, don't touch his legs. Moose got legs. Taller than a spruce. Moose got legs. Shake his caboose. Moose got legs. Stronger than Zeus. Moose got legs. He's no recluse. Don't mess with Moose. He'll turn you into juice. Moose got legs. Moose got legs. Touch his legs. No, don't touch his legs. Moose got legs. Taller than a spruce. Moose got legs. Check his caboose. Moose got legs. Stronger than Zeus. Moose got legs. He's no recluse. Don't mess with Moose. He'll turn you into juice. Don't mess with Moose. He'll turn you into juice. Don't mess with Moose. He'll turn you into juice. Moose got legs.
It works. It's done. It works. It's amazing. I love it.
It's solid.
It's super solid. It's not 100%. It needs a bit of fine tuning. Something to do with the pressure relief valve on the pump, because as you saw, we couldn't quite get the front legs to extend all the way. But for now, it's definitely good enough for what we need to do.
You all wanted to know how much it weighs and probably how much it all costs.
Let's start with the weight. Drum roll.
We worked it down to the washer.
Yeah.
Is 285 kilos. Wow, that's so light.
I think that's not too bad. It's about 8% of our payload, 7% of our total payload is taken up.
How do you work that out?
Quick maths. So It's not too bad. I don't think that's too bad. It's about what I was guessing. I thought it would be around 300 kilos. So I think that's pretty good.
Oh, we're going to start putting our running totals at the end of every video.
Cost and weight.
Cost and weight. So you can keep track and we can keep track. Next, cost.
Okay. So we had a look around, and for a kit that goes onto like a generic motorhome, like a Peugeot van or a Ford van or something like that, you're looking at between £3,000 and £5,000 fitted, and that's for off-the-shelf kind of kit that fits most of these vans. So for us, we would have had to have something pretty bespoke. So I think if we paid someone to do this, we'd be looking a minimum £7,000.
Probably even like 10,000 to have something custom that could reach up to the chassis and stuff.
Yeah.
Okay, so for the total cost of the build, it comes to £2,384.45.
That's pretty good.
That's very good. That's way lower.
Yeah, that's
Saving
a good
us about
saving.
£5,000 at least.
Yeah. Worth bearing in mind that we did get a bit of a discount on the hydraulic stuff.
Yes, approved hydraulics, and you can get a 10% discount off as well if you ask for George.
So overall, I think a massive, massive win. Well done.
Thank you. Sorry.
Oh, one last thing. I just wanted to say a massive thank you to everyone. We've just hit 17,000 subscribers.
Thank you very much.
It is insane. This whole project has been absolutely mad. We couldn't have done it without all your support, so thank you so much. If you're interested, we have a Patreon, and if you like this, we're going to do some more pretty crazy stuff with this truck, so consider subscribing.